This is an experiment.
That's how it should sound.
Bearings on these fans are going out, so might have got what I paid for on that one. This is part 2 in the Open Source Yacht. In part 1, we built a multi-point internet receiver where we could pick up Starlink, cellular, and Marina Wi-Fi, automatically failover and switch. Today in part 2, we're building the brain out of a Raspberry Pi with some interesting accessories. We're going to throw it on the board, and we're going to keep going. I gotta have a better workspace. So I'm gonna move everything up to here, and I'm gonna slowly build out what we're doing onto this board. So I'm gonna start by relocating my power supply, relocating what we put on this small board. So we have a clean slate to start with. Next thing we're going to do is assemble our Pi, program it, get it started up, get it booted, and put it into this box and start building out our network.
Alright, you guys remember my little fans. That's how it should sound.
So I think after 4 months of runtime, maybe the bearings on these fans are going out. I think I explained this is an experiment for installation on a future yacht. That's what the open source boat is. So part of my experiment is I want this stuff to run uninterrupted for months on end. I want to see that it can weather the test. So as you can hear behind me, those cheap Chinese fans that are moving air in the Wi-Fi box are already failing after probably 3 months of running. I'd say bad bearings. We probably need stainless bearings in those. We probably got what we paid for. So we're going to cut them out. Leave the case open. We don't need ventilation if the case is open. We'll deal with replacing those later. Alright, now you guys don't have to hear that noise forever. Interesting that my amp requirements just cut in half just by cutting those fans down. We're going to move on to building out the Pi computer box and the Pi computer. I'm using a Pi that I had already set up for OpenPlotter in the past. Here it is, it's a Pi 4. That's an external hard drive. We're going to use that for backup purposes later. I had it in its case, and at the time, I had a Pecan M hat sitting on top of it. Hats, as you probably know, just sit on top of those GPIU boards, and that gave me NMEA 2000 and 0183, which I'm going to continue to use. But my biggest concern at the time was Raspberry Pis are known for corrupting if they have sudden power loss. And so how do I deal with what I would call a graceful shutdown? And so I'm going to try a Pi power device, which will be another stackable hat. So let's start by taking this apart, because we're going to have it live in this case going forward and not in the smaller black case. So there's our Pi, there's our hat. We have our 32 gig SD card in there right now. So this is a new device for me. Interesting, it looks like it comes with an acrylic board template that we can mount on. We'll decide if we want to use that. So it is not a GPIU board, so it looks like it wants to sit below the Pi. 0 instructions. So I'm going to take a stab at it. The idea behind this is it's got a built-in battery, so it will send a signal to do a graceful shutdown, and it's going to do that by USB-C. So I'm still planning to bring the power in through the NMEA connection. So we're gonna have to see if that is actually gonna work. But let's build this out first. There's an on-off switch here, wired power here for positive and negative. We will read some instructions. We'll find some. So I think we'll follow what we're seeing on this picture, but we're gonna install it into a box rather than onto this acrylic plate. So what does that look like? We have a variety of studs to work with. So we'll screw in the top, we'll screw in the bottom. So I want females on both of those sides. So I'm going to screw through our box into that. I'm going to screw through the pie into that. So let's get all 4 of these studs on. Tell you what, I'm going to disconnect this battery just because it's kind of in the way. So there's that. Now the pie will sit right on top of it. So that's going to give us a lot of lift off the box. We got plenty of space. Plenty of space. Now, where's the battery going to sit? So I think what we'll do is something like this. We need connection room on this side. We need connection room on this side. So I think that's going to work pretty well. Easy enough to change if we need to. We're going to put a screw. Just screw right through this guy. Did you know that only about 10% of you who watch these videos are subscribed to this channel? Take a look at this. We'd love to see you subscribe now. Click that bell. That'll tell you when the new videos come out. You'll see what we're working on next, which is pretty exciting. We'd love to have you part of our community. The pie is going to go on. Then we're going to need a stud that is that length. So those will be what we screw down into. So we're going to put 4 of these in here. So they call them hats because they literally stack up. Now we'll connect the hat just by gently lining up and pressing down on those GPIO pins. And with our stud selection, we have almost the perfect height. It's enough for what we're doing for sure. So there is our brain, and we can keep going if needed. But we've got Ethernet, we've got USB, we've got NMEA 0183, we've got NMEA 2000, we've got HDMI monitors, we've got audio, we've got power input, although we're going to pick it up via NMEA, hopefully. And so then we're going to connect the Pi power into there. So when the Pi detects its lost power from NMEA, it's going to pick up power from this battery, and it's going to initiate a safe shutdown process. I don't need it to run forever. I just don't want the data corrupted on the SD card right here. I want it to shut down safely. And then we can put another expansion on here or pick up these individual pins if needed. And it'll all fit in this box, and like what we did the first time, we'll ventilate it, but the goal is to keep moisture, dust, humidity, and all that stuff out of there. On the box, we'll have Ethernet, NMEA, and some other things coming in there. Same way we did the Wi-Fi. Just create a nice, almost atmospheric connection. Again, the fans are the things that I'm having to use that don't give me a closed atmosphere. If you have a better idea, I'm happy to hear it, but I know I gotta cool these things down. So ideally though, we're gonna look at something like this. I won't connect it down yet, but it'll probably look something like this when we're done. All right, I think we're gonna put the battery right here. It's giving me clearance away from the box. I can still get to screws. There's no connections in this area. So, fellas, never fail to go to Hobby Lobby with your wife, because there are things there you need. Cushions for the whaler. I got this little kit to store all of the little stuff I need for the pie. So, I'm going to need some waterproof terminals, screws and offsets. That's what I was just using. Let's see what I've got in here. Here we go. This is what we're talking about. Alright, so what am I going to need? And what do I have? I'm going to need Ethernet. I need NMEA 2000. Which I think I have somewhere. Those are all I2C connectors. So I think I'm going to make a call on this box. I don't have all of the connectors I need. I'm going to need one, maybe two monitors, Ethernet, USB, power, and the NMEA 2000. So I'd have to have these all the way around. We know it's not going to be a fully waterproof box. I don't need it to be a fully waterproof box. High humidity environment inside of a boat is what I'm worried about. We're going to have a fan somewhere on this box that is moving air through it. So there's going to be a hole there anyway. I think I'm going to drill a hole, pass all the cables I need through it, put some kind of compression sleeve on it to make it roughly waterproof. I also think I'm going to do a different fan design this time. I think I'm going to put the fan on the bottom and put a mesh cover hole in the top. Just let the fan pull air through or push air through, probably pull air through. So one fan instead of two, and see how that works. Again, like, I'm not happy with the fans we used before. They're supposed to be a brushless fan, so I don't know. We might give them another shot here. The current ones are Maker Focus, which were highly reviewed. So we'll see. One of our viewers last time suggested I get some screens to put over these fans, so I'm actually going to do that on this box. So, you know, look for your fan size on Amazon, and then we're going to install it like that, but in the top, I'll just use the cover. We'll just be pulling air through it. Again, I'm not trying to give you instruction on how to do this. I'm trying to show you the decisions I made on, again, what I'm calling an experiment. Experiments imply possible success or failure, and, you know, so far so good, minus some of those original fans. Let's see, I do have some rubber grommets. So these are 1-inch rubber grommets. I think I'd probably put 2 of those in. And again, I got to think about cabling going through there. Then our fan, we're going to use a 1-inch hole saw for those guys, and for the fan, 1 3/8. Do a hole in the bottom for the fan, a hole in the top for the airflow, and then 2 holes in the side on the box's right side for the connections, which is where a lot of them come in. So we are 6 inches. So there's 3, and we're going to come up 1.5. So 6 inches and 1.5. And we need a bigger drill. We got to get old Blue out. Say what you want about Ryobi tools, man, but I've used this drill for building houses and decks and all kinds of stuff. It's never failed me. Okay, so we said this side, we know we're coming up 1.5. The whole box is going to be 7, probably 8. So the center is right here. I'm going to come off that line. 1.5 left, 1.5 right. Here are my drill locations. Switch back to the Milwaukee on this one. down with hole saws, file and clean that up. Should be able to put our 1-inch grommets in these holes. This may prove to be the most difficult thing I've done today. Alright, one in, little flathead, certainly helps me get underneath that lip and push it in. So, there are those. So now we're going to put fan on this side and on the back, screw it through. Alright, my screens came pre-drilled except one of them wasn't drilled out. So let's clean that up. Punch in it, and it did it. Just eyeballing where these holes should be. So I'm going to do these with bolts that attach through. So it's going to go screen, the wall, then the fan. Looks like I'm just barely the right size. So let's try to thread these through here. That's not a bad thing at all. Fan's gonna go on the inside of this hole. There's a stud right there. Could be a problem. I can slide that guy below it and I can get access. So now we're going to put the top screen on. Monitor, Ethernet, USB, NMEA 2000. Let's cut these excess bolt length off real quick. Before we assemble all this, let's test it. So the instructions I found online say battery will not work till external power is applied first time. This is the external power for this high power. So we're going to plug that in. We get a power light. We are in the off position right now. Okay, I now turn the switch on. We've clearly powered up the Pi. And we've got power light and then 3 of 4 charge lights. So I'm going to leave this, see if our charge comes up to 4 of 4 just as a test. And we'll put everything in the box, get it assembled. Okay, some time's passed. You'll notice our battery indicators are now fully charged. So I think we are ready to go. The Pi is booting and transmitting data. So we're gonna throw it in the box. We're gonna get it up on the board. And then in the next part, we're gonna start building the network and booting everything up. So I'm thinking if I disconnect this, we're gonna keep operating because we get the battery. So let's see what happens. Yep, we are definitely still on. The Pi is still operating. So that's awesome. We've still got power. Let's put the Pi in the case. We cut those studs off, tighten everything down. Let's start bringing power into this thing. So I'm going to get an adapter and tie into power for the fan. So we're going to leave the box open and not have a fan yet. Let's bring USB-C in. NMEA 2000. Barely fits through the grommet. Ethernet. USB. Alright, we're going to run this in a headless configuration, so we will remote into the Pi. So that should be it. So no monitor connections. The USB I'm taking to a hub, powered hub, so we won't need more. We're gonna connect our fan later. So next step is to network this all together. We're gonna build a USB hub, an Ethernet hub, and a NMEA 2000 network, and then we're gonna connect it all up. Stay tuned.